Hi, welcome to another video where we are seeing the solutions of AEC and ME number 8. So for the circuit shown below and for the given waveform, write the output waveform. Assume plus or minus Vsat as plus or minus 5 volts. For each and every circuit, we are asked to find what is the output waveform. There is an input being given. So in this first question, we have applying an input voltage at non-inverting terminal. The inverting terminal is grounded. The input waveform that I am applying is the V in 1. So V in 1 happens to be a sine wave of amplitude 3 volt and in some frequency. So let us see the answers for this. Okay, this is the circuit what we are looking at. So we have a now I hope this recording is fine. Okay, it's fine. We are looking at what is the output of this. So since we know that this is a open circuited circuit, so V01 will be equal to plus Vsat, or will it be equal to plus 5 volts if V plus is greater than V minus, and the same will be equal to minus Vsat or minus 5 volt if V minus is greater than V plus. Actually, if you see this, what is V plus? Actually, this is V plus, and V minus is actually grounded. So I can treat this as my V minus. Now, let us find out in which region of the waveform V plus is more and V minus is more. Suppose if I just bifurcate this here. See now, in this entire region of the input voltage is V plus more than V minus. So now here output voltage will be plus 5 volt, and if you see this region, so that is region 2. This is region 1, this is region 2. Can you see this is my V plus and this is V minus. So here it is 0 volt, here it is negative voltage. Here V minus is more than V plus, so output voltage has to be minus 5 volt. Again, this is plus 5 and this is minus 5. Then how do I plot the waveform? The waveform will be, suppose if I write this as my T, this is my V0, which is 0 volt. So during the positive half of the input voltage, the output voltage is plus 5. So during the negative half, it is minus 5. So this is how it is changing. So this is a square wave with amplitude as plus 5 volt during the positive half cycle, and this is minus 5 volt during the negative half cycle. You are actually comparing the input sine wave with 0, so that's why you can call this circuit as 0 crossing detector. So it actually detects when your input crosses 0. So when it is crossing 0 and going positive, the output voltage is plus Vsat. When the input is going crossing 0 and going negative, the output voltage is minus Vsat. So this is as simple as that. So let us take the next circuit. So now in this circuit, it's again the second problem. So where you are having the non-inverting terminal is connected to 1 volt and inverting terminal is something like this waveform. Now, do you see now? So this is the waveform which is there at V minus. So what is the voltage at V plus? So voltage at V plus is 1 volt. So let me write that also. So assume that this is 1 volt. So is this V plus? So if you compare both the waveforms, so because one of the waveform at V plus, that is non-inverting terminal, is 1 volt, which is far above this 0.5 triangular waveform. So if you see this entire waveform, if I want to write what is V02 with respect to time, do you see for the entire input waveform timing, is your V plus is always more than V minus? So again, since it is in open loop, V02 will be equal to plus 5 volt if V plus is greater than V minus, and this is equal to minus 5 volt. So let me just bifurcate here. This is equal to when V minus is greater than V plus. Looking at this waveform, V plus is always more than V minus. So this condition is true all the time. So what will be your output voltage? If this is V0, if this is 0 volt, does your V02 is always 5 volts? So let me write it as, this is my 5 volts. This is, if this is 5 volt, so is this my V02? V02 is 5 volt because your V minus is never exceeding that 1 volt. So it is the input voltage is compared with 1 volt. Since your input is not exceeding 1 or minus 1, so output voltage is always at plus 5 volts. So output voltage is plus Vsat, which is nothing but plus 5 volt, because my input is not crossing this comparator or this voltage of 1 volt. Fine. Let us see this now. So now this is no more a comparator. This is having a negative feedback with the resistor RF as, so let me write this as RF, which is the usual naming we do for a feedback resistor. So what is V03 now? It's actually EV times V in 3. What is EV? It is minus RF by R1 into V in 3. So what is RF by R1? This is actually minus 2K by 1K into V in 3. So actually the gain of this amplifier is minus 2 times V in 3. So what are the input you have? You have an input voltage of 1 volt during the positive half, minus 0.5 during negative half. So what should happen now? This input 3 will be multiplied by minus 2 to get the output. So what is 1 into minus 2? It's actually minus 2. So when the input is positive, you will get minus 2 volt. So when the input is minus 0.5, what is the output you are expecting? So this is minus 0.5 into minus 2, which is plus 0.1. See now, is it plus 0.1? So now over here it is minus 2. This is again plus 0.1. This is actually, how much is this voltage? It is minus of 2 into minus of 0.5, which is nothing but 1 volt. How much is this amplitude? Minus of 2 into 1, because the input is, how much is the input? The input is 1 volt here. The input is 1 volt, or this amplitude. So this is nothing but minus 2 into 1, which is nothing but minus 2 volt. So it varies from minus 2 to 1 volt. So let me again repeat. Since the gain is minus 2, the waveform is flipped here. But the amplitude, since it is 1 into minus 2, you have minus 2. Here it is minus 0.5 into minus 2 is 1 volt, plus 1 volt. So this is flipped to above by 1 volt. This is flipped bottom at minus 2 volts. Okay, let us see what it is here. Of course, there is no waveform given. So what is this you have? So the input is, again you have a feedback which is a negative feedback. So what is gain now? Input is given to non-inverting terminal. If I want to write what is V04, is V04 is equal to V in, let me say it as V in 4. Is it V in 4 multiplied by this resistor 2K by 3K multiplied by gain of this. So how much is this gain? So this gain is nothing but 1 plus 4K by infinity. 4K by infinity, because this is your R1 is infinity. How much is this now? Is it a gain of 1? Is this having a gain of 1? Because this is effectively a voltage follower. So then what is the voltage? Here you have it as 2 into 2 by 3. So it is 4 by 3. It is 4 by 3. That is the voltage what you are having. So it is now 4 by 3, which is 1.33 volts. So whatever voltage that you will get it as 1.33, same will be coming over here as 1.33 volts. The waveform is, it is a DC voltage 1.33 volt with respect to time. Now let us see what is this is. See, I have a signal here. If you can see, the feedback is positive. The feedback is positive given here. Now what is the gain of the amplifier? Gain of the amplifier is more than A0. In such case, the output is either plus Vsat or minus Vsat. So it cannot be less than that. So it cannot be a sine wave. So output voltage is either plus phase side or minus phase side. Maybe we will now, what is the voltage at this point now at non-inverting terminal? The V plus is, suppose if you assume this to be 5 volt, the voltage at this point will be how much? Is it not 5 into 4 by 5? So will it not be 4 volt? Sorry, it's not 4, it is 1 by 5. So is it actually 1 by 5? Because the voltage at this point is 5 into 1k by 5k. This kk will go off, this will go, this is 1 volt. So you have a reference of 1 volt, you have a reference of minus 1 volt. If the output voltage is plus 5, then it is 1 volt. If the voltage is minus 5, then the voltage here is minus 1 volt. Now the question is, if the input is more than 1 volt, then output is at minus phase side. If the input is less than minus 1 volt, then output is plus phase side. So what will happen here? See this, E05 is, I'll just write this transitions. If the input is more than 1 volt, then it is minus phase side. So let me write this as minus 5. So may not be scale wise, it may not be minus, not looking like minus 5. Okay, let us say this as minus 5, this as plus 5. So since, okay, assume that initially output voltage is plus 5 volts. When the input crosses 1 volt, so when the input crosses 1 volt, is it more than 1 here? So V minus is more than V plus, then output go to minus phase side. So if the input voltage goes less than minus 1, if it is goes less than minus 1, so does your V plus is more than V minus? So in such case, output goes to plus V side. So output is a square wave of plus 5 volt minus 5 volt, having the transition happening at plus 1 and minus 1 volts. Plus 1 and minus 1 volts. Okay, that's fine. Okay, maybe we'll exactly learn why it is plus 1, minus 1, maybe in the next AEC and me, that is a Schmitt trigger. This is basically a Schmitt trigger. So we will see effectively how it works as a Schmitt trigger. And again, how about this? So this is having, again, it has got two outputs, V061 and V062. What is V061? Okay, let us consider this as 1, this as 2 waveforms, 2 inputs. So what is V061? Is it not 2 into minus 200 by 1000? Because that is the gain you have. And what is V06? Is it not 1 into 1.5 by 1.5 plus 6.8 into 1 plus 0.2? So how much will be this? So this is actually, this will become minus 0.2, that is 200 by 1000 is 0.2 into 2 is minus 0.4 plus of, it is 1.5 divided by this is 7.3 multiplied by 1.2. Is it not 0.246 minus of 0.4? Is it minus 0.153? This is actually the voltage. So the voltage is minus 0.153. Now you can see this is the output voltage due to this, which is nothing but 2 into the gain, which is 200 by RF. Now this, the voltage that is coming out here is out of 1, it is 1 into 1.5 by 1.5 plus 6.8 multiplied by the gain, which is nothing but 1 plus 0.2, which is 1.2. So 1.2 multiplied by the ratio is this, and this is minus 0.4. So this comes out to be this. Okay, fine. We will see the next one also. So this is basically you are actually plotting the waveforms with respect to the applied input signal, whether it is sine, triangular, or square waveform. So we will see the next one, that is AECN 9. So AECN 9 happens to be, where is that? Okay, let me just see this. Okay, this is my AECN 9. So we are asked to find the value of R1, R2, V reference for the following upper threshold voltage and lower threshold voltage, which is also called as VTH, VTL. Given we have been given the values of VTH and VTL, we are asked to find what is R1, R2 and V reference. And of course we are assuming the value of plus or minus V set as plus 5 and minus 5. So let me just take this here and have this as a reference. Let me have this over here. Let me make this smaller one, because I'm just looking at the design of. So this is a solution for AC and me. This is number 9. This is Schmitt trigger. This is Schmitt trigger related circuits. Now let me just write the Schmitt trigger. This is minus plus. You have a positive feedback. This is R1. You have a V reference also. REF. This is V reference. This is R1. This is R2. Maybe till that time I write the equations. Let me make it single. This is your V in. This is V naught. We know that since it's a positive feedback, the output voltage is either plus Vsat or minus Vsat. It cannot be anything other than that. It will be, suppose since you are assuming plus or minus Vsat as plus or minus 5 volt, output will be either plus 5 volt or minus 5 volts depending on the input. If the input is more than, okay, let me write this. So this is my input waveform. If I write this as a VTH point, and if this is, of course, VTH, VTL can be both positive, both negative. One can be positive, one can be negative, or both can be negative, both can also be positive. If I assume this, so VTH is positive, VTL is negative, what happens to my output is, if V in is greater than VTH, my output is minus Vsat. If V in is less than VTL, so then V naught is plus Vsat. So this is what we are looking at, which is very natural here. So this is going to have either VTH or VTL. The voltage at non-inverting terminal will be either VTH or VTL. Suppose if the voltage at the inverting terminal, okay, what is this basically looking at is, so this is actually V minus is greater than V plus. Are we just having this? When V minus is greater than V plus, naturally it is minus Vsat. And what is this? Here it's again V minus is less than V plus. So then what is the output voltage? Because now this is exactly equal to V plus greater than V minus, because V minus less than V plus can also be written as V plus more than V minus. Can you see now, is the output voltage plus Vsat? This is what the concept is. The output voltage is either minus Vsat or plus Vsat, because the gain is more than A naught, more than A naught. Now the question is, what is this VTH, what is this VTL? So VTH, I will call it as a higher threshold voltage or upper trigger point, So when you have this, if you want to find VTH, I will consider this output voltage to be at plus Vsat. If you consider this as plus Vsat and if you have this as V reference, so because of these two voltages, I will have a corresponding voltage at this point, which will call it as VTH. So basically, what is VTH? VTH is due to this as well as this when the output voltage is plus Vsat. So now, can I write VTH? can write VTH as equal to, when I have both the inputs, let me consider one at a time. So when I am considering this plus Vsat, I will treat this as 0. If I treat this as 0, if I take it as plus Vsat, the voltage at the non-inverting terminal, is it not equal to plus Vsat into R2 by R1 plus R2? This is due to potential divider. So voltage at this point due to only this is Vsat into R2 by R1 plus R2. This is due to only V0. So what is the voltage when you consider this and not consider this over here? It is now plus of V reference multiplied by R1 by R1 plus R2. R1 plus R2. So VTH is the voltage at the non-inverting terminal. This is the voltage at the non-inverting terminal when output voltage is plus Vsat. So if I write this R2 by R1 plus R2 as beta, then if you do 1 minus beta, it comes out to be R1 by R1 plus R2. It comes out to be this. So can I write this as equal to, in a simpler form, plus Vsat beta plus of V reference into 1 minus beta, where beta is R2 by R1 plus R2. On the same lines, if the output voltage is minus Vsat, then what are the voltage at this point, which I'll call it as VTL. So VTL again at non-inverting terminal, if output is minus Vsat, you can see now I'm writing it as minus Vsat R2 by R1 plus R2. Then this is when this is minus Vsat, so that is at this point due to this source. So due to this source, what are the voltage? Another fraction of the output voltage, is it not? Or the voltage at this point due to this V reference when the output voltage is minus Vsat, is it not V reference into R1 by R1 plus R2? So does this equation of VTL, will it not become minus beta Vsat plus V reference 1 minus beta? This is what we're going to get, correct? So now keeping this in our mind, let us try to plot the waveform also. Of course, this is the equation wise, this is actually V minus, this is V plus, this is also V plus, depending on when output voltage is plus Vsat and the output voltage is minus Vsat. Now see here, since it is that sine wave is connected to inverting terminal, as long as V minus is more than V plus, this is V minus, this is V plus. So since V plus is more than V minus, is your output voltage plus Vsat? The output voltage now is plus Vsat. So let me write the region over here, let me write the region over here. See now, in this region, in this entire region, is V plus greater than V minus? In this region, see here, the red is more than the blue, so output voltage is plus Vsat. If your input voltage crosses this VTH, so does this is more than VTH, so then output goes to, so here V minus is greater than V plus, it goes to minus Vsat. This was plus Vsat, this is now minus Vsat. The moment this goes to minus Vsat, the voltage here become VTL. So this is your voltage. So this is now V plus. Now you are comparing this and this. So in this region you are comparing this and this. So which is more now? can you see this V minus is always more than this here, this V plus, so output voltage remains as minus V sat. Till when? If V minus goes lesser than V plus, so then which is more? V plus is more than V minus after this time, so output goes to plus V sat. Output goes to plus V sat. The moment output goes to plus V sat, then this V plus will become this voltage. So during this region, this is more than always this, because this is your, now what you have to compare now is this is your V plus and this is your V plus and this is your V plus. You can see V plus is keep changing. So which is, what is V plus here? The V plus is this when the output voltage is plus V sat. So you are comparing V minus with V plus. So since V plus is more than V minus, output voltage at plus V sat. Till when? When the input voltage crosses this, now V minus is more than, so here what is this? Is it V plus greater than V minus? So that's why it is plus V sat. See here, now once the input voltage, that is V minus, crosses V plus, can you see here V minus is greater than V plus? So is it minus V sat is your output? Output goes to minus V sat. The moment output goes to minus V sat, the V plus also becomes VTL or the negative voltage. So now this continues. Now what we are looking at now is when the input voltage crosses VTH. When the input voltage crosses VTH, output voltage is minus V sat. If the input voltage is going below VTL, when I say below VTL, more negative than VTL. When it is more negative than VTL, you will get plus V sat. Plus V sat. So keeping this at the background, let us try to get the values for these. Let me again zoom this. So we want a VTL of 3 volt. We want to have a VTH of 3. This is of minus 1. So now, okay, first problem is VTH is 3 volt, VTL is minus 1 volt. We are asked to find R1, R2, V reference, assuming plus or minus V sat is this. So now, if you consider these two equations, so now if I add these two equations and if I subtract these two equations, suppose if I do VTH minus of VTL, suppose if I take the difference of this and this, so what will happen to this? It is beta V sat, and this minus of minus will become plus beta V sat. So I will end up with 2 times beta V sat. So 2 times beta V sat is nothing but 2 times R2 by R1 plus R2 into V sat. Correct? This is the equation what I am going to get upon making VTH minus of VTL. What is VTH plus VTL? I am just adding these two terms. So when I add these two terms, does this plus minus beta V sat go off? This will go off. I will end up with addition of these two. Is it not 2 times of V reference into 1 minus beta, or is it not 2 times of V reference R1 by R1 plus R2? These are the two basic terminologies I should know when I am solving this problem. See now, these are the two voltages given, the difference will give you this, the summation will give you this. So now, since I know this voltage, I know this, let me find what is, so what is this here? 3 minus of minus 1 is equal to 2 times R2 by R1 plus R2 into V sat. How much is V sat? It is 5 volt. So do I get some relation now? Is it not 4 is equal to 10 R2 by R1 plus R2? Can I write now 4 R1 is equal to 6 R2, or can I write R1 is equal to, can I write it as 6 by 4 R2? I can write it as so and so. Correct? Now, once I have this relation, so let me take this. So is it not 3 plus of minus 1? is equal to 2 into V reference into what is R1? It is 6 by 4 R2 by 6 by 4 R2 plus R2. Correct? This is I'm replacing what is R1 is. So R1 is 6 by 4 R2. This is 6 by 4 R2. So what is this now? So this happens to be 2. This is 2 V reference. So let me just take out this. Is it not 6 by 4 R2 by 1 plus 6 by 4 R2? This R2 will go off. Will I get the value of V reference? So what is V reference now? So I will take how much is this? It is 6 by 4 plus 1 plus 6 by 4. So this 2 and 2 will go off. So I am trying to find what is V reference is. Is it not 6 by 4 divided by or 1.5 divided by 2.5? It's actually 0.6. So is this actually 1 over 0.6? What comes out to be is, this is 1 is equal to V reference into 0.6, then V reference is so and so. What is 1 over that? It is V reference is 1.66 volts. Now I need to have a V reference of 1.66 volts. Here let me assume, because I know this relation, let R2 be 10k. If R2 is 10 kilo ohm, then how much is R1? R1 is actually 1.5 times of R2. This will become 15k. So if you have V reference of 1.66 volts, if R2 is 10k, then R1 has to be 1.5 times, it is 15k. So with these values, I can get a Schmitt trigger with VTH is equal to 3 volt and VTL as minus 1 volt. On the same lines, you can do it for this. What is the second problem? The second problem is this one. So it is 2 and minus 4. So VTH is 2, VTL is minus 4. If you make this VTH minus of VTL, what you will get is 2 times VSAT R2 by R1 plus R2. So this is basically true if I have this as R1, R2 and V reference. So if you name it as R2, R1, then the expression will change. So you have to be very careful. So now how much is this? It is 2 minus of minus 4 is equal to 2 into 5. So this is R2 by R1 plus R2. Using this, I will get a relationship between R1 and R2. Is it not 6 is equal to 10 R2 by R1 plus R2? Is it not 6 R1 is equal to 4 R2? So what is R1? It is 4 by 6 R2. 4 by 6 R2. 4 by 6 is, okay. Now it is R1 is equal to 0.666 R2. So upon taking the addition, VTH plus VTL is equal to 2 times V reference into R1 by R1 plus R2. So this is actually 2 plus of minus 4 is equal to 2 into V reference. So how much is R1? So let me write it as 4 by 6 R2. Here it is 4 by 6 R2 plus R2. So now is it not minus 2? This is 2 V reference. So it is now 4 by 6 by it is now 10 by 6 R2. So now this comes out to be, okay, R2 will go off. So what you have is this will go, it is now this will also go. So what is minus 1? V reference is 4 by 10. So will I get V reference is equal to minus 10 by 4 is equal to minus 2.5 volts. So my V reference is minus 2.5 volts. So now how much is this? You can take R2 as, so you can take R2 as 10 kilo ohm, or if you take R2 as 6 kilo ohm, if you take it as 6 kilo ohm, then what will be your R1? R1 is equal to 4 by 6 into 6, this will become 4 kilo ohm. So R1 is 4 kilo ohm. This is 2.5. Suppose you want to verify whether our calculations are correct or not, let us find what is VTH. What is VTH? It is Vsat R2 by R1 plus R2 plus of V reference R1 by R1 plus R2. What is VTL? VTL is minus Vsat R2 by R1 plus R2 plus of V reference, this is what? R1 by R1 plus R2. Let us plug in the values there. So how much is this? Is it not 5 into, how much is R2? R2 is 6K by 10K plus of, how much is this? This is minus 2.5 into R1 is 6K. R1 is actually 4K. 4 by 10. Correct? How much is this now? 30 by 10, which is 3 minus, what is this? Is it not 2.5 into 4 divided by 10? Is it not 1 volt? Are you not coming this as 2 volt? Is this is what we started with? What is this? Can you see this? VTH is equal to 2 volt. That's what we actually found. This is actually 3 minus 1 is 2 volt. So we are trying to simply verify whether our findings are correct or not. Again you do this. Is it not minus 5? So what I have is minus 5 into R2 is 6 by 10, because this is 4 plus 6 plus of 2 point, of course minus 2.5 into 4 by 10. 4 by 10. So is it now again minus 3 minus 1, is it not minus 4 volt? Are you not getting minus 4 here? So this is minus 4. So likewise, once you find the value of V reference R1 R2, you can basically go back to this and refine whether you are getting the original value of VTH and VTL. So this is a proof of that. Okay, likewise you can certainly do it for the other values of this and this. So maybe in the next video we'll see how to plot the transfer characteristics.